Those of you who have not been to a jQuery conference and not seen Adam performing before, I do want to say that by the time you get to the end of the conference, this will remind you of Adam. He's got an interesting sense of humor. I love memes. So you probably all know about jQuery the code. That's where usually people identify when I say jQuery, you say code, jQuery code. But there's more than just code to jQuery. In particular, the documentation, we often get complimented on the quality of our documentation, and we take pride in it. We also do things beyond just the library itself. We support web developers and web standards. When you think about it, the web developer, the web standards community is primarily consisting of people who are writing browsers. And those people may not be the best to know what web developers need. And so we act as an advocate on your behalf in places like the W3C and ECMA 262, which sets the JavaScript standard, so that your voice will be heard. And of course, we host conferences like this so that we can all learn more and have fun. Just a couple of short words here about the most recent release of jQuery Core, which is 1.11 and 2.1. We are maintaining the two different branches. The 1.11 branch still supports IE 6, 7, and 8. The 2x branch does not. A little tighter, a little smaller, a little faster. The release that we just did is really focused on making jQuery so it can be used in more environments, and it can be used and included in more ways. So, I coined the term jQuery served your way. Yeah, it's like Burger King. And you can also, we've increased and improved our process for doing custom builds so that if you say, jQuery is bloated, it's too big, I don't need half of it, well, then you can cut out the half you don't need and make something half the size. You can also use it with Node, with Browserify. You can use it inside apps like PhoneGap. You can use it in environments where you might traditionally not think of jQuery as being the primary way to develop. But if it's HTML and if it's JavaScript, you can use jQuery there. That's our goal. Now here's some statistics about jQuery. You can tell that it's used in 68.4% of the top 10,000 sites. Wait. That number looks wrong. That's crazy. That can't be right. Oh yeah, this is the data from November of last year. This is the data from February. 75% of the top 10,000 sites now use jQuery. It's gone up. So for those of you who want to know the two words that are most important about jQuery, job security. You will never go hungry again. And the popularity surprises me. One day, I guess at the rate we're going, we'll be in 150% of all websites. I don't know exactly. Of course, some people include 2 copies, so maybe we're giving them credit for 2. I don't know. But it amazes me every time I see this graph. The jQuery team, which actually delivers all these wonderful things to you, is all over the world. And not only are the team members all over the world, we've accepted pull requests from every continent except for Antarctica. And I want to say how disappointed we are in Antarctica. We think that maybe we can teach some penguins to code because, of course, on the internet nobody knows you're a penguin. If you would like to contribute, whether you're a penguin or not, you can go to contribute.jquery.org and learn more. My talk was going to be about Flappy Bird, but it turns out you can't get it anymore. So I had to change the talk. It's going to be about performance, which is something that everybody wants to know more about. All your friends are always like, it's slow, it's slow. I hate developing in the browser because it's just so hard to do anything, and jQuery makes it hard, and people complain all the time, right? And then they say, well, jQuery overhead, everything is too expensive. jQuery is costing me a lot. Yeah, the old saying is true here. A poor workman does blame his tools. There's a lot of good things that you can do. Even if there are flaws in the browser platform, in JavaScript, and jQuery, there's things that your knowledge can help you avoid those flaws. And I think part of the reason why people do not do not really get the browser platform at first is this is the way they see things working. That, you know, if you come from a programming environment, say like a server, you see JavaScript code as being the most important thing in the world, and everything else revolves around it. And the browser is really just a runtime library. But really, it's just the opposite. The web developer really has to come to terms with the fact that they are not the center of the universe, that the browser is doing a huge amount of work for you. It's not just a runtime library. It's this incredibly rich engine with features. And your JavaScript gets called at times that are convenient for the browser. You know, it's like, I've finished loading. You want to do something? This user just clicked on this. And your JavaScript then gets control. But to give you an idea of where you stand in the pecking order, when you think about it, the browser can do an awful lot without any of your JavaScript. And in fact, it'll probably run a lot faster. But we know that people want to enhance pages, right? So how do I enhance the page but still make it run fast? Well, it's really a two-step program. You just find the slow stuff, and you make it not slow. Well, that will, of course, bring the question of, how do I find the slow stuff? Well, there's a lot of ways and things that you can do to measure on a web page. There's a lot of things that you shouldn't bother measuring. And I want to give you some examples of things that sometimes you will read on the internet. People will say, you know, this is something that I compared these two ways of optimizing loops, and it's amazing how this is twice as fast as that. And they're right, it is twice as fast. But it turns out that even the slowest way to do a loop, you know, while loop, a for loop, from 0 to n, from n to 0, even the slowest way of doing it in this particular benchmark was plenty fast enough for what people do. And that actually points out something that Donald Knuth said probably 30 years ago. He said that all of us programmers like to waste time kind of figuring out how to make this a little bit faster here and there. And in the process, we probably kind of screw up the code. There's the other old saying that says you need to write your code for two people, yourself and yourself 6 months from now. And that's really true. You know, you spend your time optimizing, and then 6 months from now you come back and you say, oh, geez, why did I do that? So we want to forget about doing those little micro optimizations that really weren't the bottleneck to begin with. And we want to focus on the 3% of the code that really is the bottleneck. So most of the time, that 97%, you want to just do the obvious thing and revel in that first world problem of, gee, this wasn't the slow thing. I didn't need to work harder on it. But we do need to focus on that 3%. And the good news there is, don't let anybody tell you that, you know, you've got to start with a firm architecture for doing this, and if you don't, you'll have to start with an empty HTML file. No, that's not true. Most of the time, you can just do a peephole optimization. And in fact, you can actually do it after you've deployed. I mean, that's the good thing to do, right? I mean, your boss says, hey, this is too slow, fix it. Well, fix the thing that's slow when you determine that it's too slow. And one of the things that people often complain about on web pages in particular, and apps as well, is page load performance. So let's take a look at some things that we can do to make page load performance faster. Just to give you an idea of kind of a high-level view of what the browser does when it's loading pages, you know, the browser fetches the HTML file, and then there's a thing called the prefetcher, and all the browsers pretty much work the same this way. There's a prefetcher that even as the browser is fetching the rest of the page, starts to go through and find things that it thinks it might be able to fetch for you. So if there's a kitten.jpg inside that file and it finds it, it'll say, this image is probably going to be displayed. Let me go get that started while I'm waiting for the other stuff to come in, because that way we overcome some of the network latency. When it comes to JavaScript, the browser is somewhat hindered because it needs to actually run the JavaScript at the point where it's encountered in case that JavaScript is going to write something into the document. Now, there's some ways around this, but 95% of the time, JavaScript is going to run in place, and the browser will have to wait for it to finish. So the lesson there is you want to try to include as little JavaScript as possible, just jQuery, and all the rest of it try to do after the page is loaded when things are a little less critical. Once the HTML is fully loaded, then the browser calls the DOM content loaded event, which equates to jQuery.ready. You want to watch out for that because the user still hasn't seen anything. So the more stuff you do in the ready call, the more you delay and worsen the user's perception of performance. And finally, as the final step, the browser gets the chance to draw things. Now, it may not be obvious, or at least maybe you have to connect the dots, but resources that are not in the HTML file can't be prefetched. You can't overcome that network latency unless you take advantage of the browser's ability to prefetch. So if your model for doing things is to wait for the HTML to load and then call an AJAX that grabs a JSON response that you then turn into HTML and inject into the page that happens to have a JPEG file, then you've already done 3 or 4 extra network loops that you didn't need to do, and you've delayed the way your page renders. Now, it turns out that if you use some frameworks like Angular, for example, that's kind of, they need to run and do the processing of the page before they can inject and render the content. So you have to be a little bit careful when you're talking about performance. If you're going to use one of the MVC type frameworks where you're generating content out of templates, that you don't end up bottlenecking yourself trying to generate a lot of content and having to wait for those extra network processes. There's actually some features that you can use that almost all the modern browsers support. Prefetching, you can DNS prefetch that says, I'm going to need something from this domain in the future. Look it up so you'll know the IP address before we get there. And you can also say, I want to prefetch specific resources, like I know I need that kitten.jpg in my template coming up, so let me go get it now, so that way you overcome the problem of waiting for something to load before it knows it needs it. Now, there's also some really great tools out there that you can use to help figure out your load time bottlenecks. I'm just going to go through these quickly, and you can certainly search for them, and if you're not familiar with them already. YSlow, which is a great browser plugin that will give you tips on specific things that could make your page run faster. There's Google PageSpeed, which also gives you specific tips on problems that you might encounter and specific advice on how to solve it. There's modern.ai. Full disclosure, I actually worked on this website. It will go through and find things that you are doing, especially in older code, that you did to make IE7 work, but ends up screwing up newer versions of Internet Explorer. So those can actually cause performance issues as well. But the tool that I think everybody should definitely be familiar with who's trying to optimize performance, especially when you're dealing with a worldwide audience, is webpagetest.org. And if you're not familiar with this one, you definitely should be. It allows you, if you look at the red circle there, it allows you to select from a wide variety of places on the face of the planet where you want to make your requests. Basically, you want to say, assume I'm a user in Moscow or Seattle or wherever, and I've got a cable connection. Then that's the basis for the performance analysis. So rather than just saying, usually all of us kind of load it off our local disk, off of localhost. It all works really fast when it's on localhost. This will actually tell you what it's really like coming from a place that you're not at right now. And it will give you grades. This page did not make a really good grade, did it? But the thing that you want to know is not just the grades, but how to improve your grades. And it turns out that if you remember back when I showed you Google PageSpeed, the #1 thing there was to remove render blocking resources that were in the head of the document. And the render blocking resources in this case are advertising. And in fact, they're horrible advertisements. If you look there at the yellow stripe, the reason that was marked yellow by Web Page Test is because it's a 302 redirect. So it's the sad case where the browser goes to get some information, and the information takes the round trip, and it comes back and it says, oh, by the way, these are not the droids you're looking for. What you really need to go is make a second request, number 15 there, and that will actually be the content you were looking for. So if you look at that total, what is it, 250 milliseconds or so, 225 milliseconds, that it took to do that whole round trip, when it could have been a lot faster if there wasn't a redirect in there. But on top of that, that ad is a render blocking ad. What happens is that script runs and it does a document right into the document. So it's like the worst case nightmare scenario for the browser. It's sitting there, it's waiting for the script to come back from that redirect, and then it has to wait for it to execute so it can write some ad tag, some script into the document. So ads are often, when you talk about how can I make my page faster, it turns out a lot of these ad networks don't do a very good job of optimizing what they should. So in this case, this page only took 0.8 of a second to load, but almost a quarter of a second of that was the ads trying to load. Not a very good thing. So we looked at load time performance there. You got an idea of what a waterfall diagram looks like. Those waterfall diagrams you see at web page test can also be generated by the tools in your web dev tools like Chrome and Internet Explorer. But what about once the page is loaded? What kind of things can I do or not do to make my page faster? Well, one thing that's really important to learn is there's kind of this 16 millisecond mantra that if you're thinking about performance, you need to keep in mind. And there's 16 milliseconds that it takes to, that's kind of the frame rate of the browser. Things happen, and every 16 milliseconds it would like to draw something to the screen to give you a 60 frames per second frame rate. If you, in your JavaScript or other activities, make something take 60 or 70 milliseconds, then that will be a visible jerkiness to the user as they use your page. And you don't want that to happen. And of course, if you make it really bad, if you have something that takes 2 or 3 seconds, when the user hits a key to type something into a box, it won't even show up sometimes. This is what really amazes me, is all of this stuff happens in 16 milliseconds. And essentially what happens is the browser renders the HTML strings that come out of the files into a document object model in memory. Does the same thing with the CSS. In most cases, your JavaScript is tormenting the DOM or the CSS OM. It will sometimes go back and take some HTML strings and then turn those into a DOM and inject that into the DOM. But the browser needs to take those two, combine them into what it calls a render tree, then figure out how the page is going to be laid out, and then actually paint it on the screen. And in the best case, that happens all in 16 milliseconds. And it's amazing that it actually usually does happen in 16 milliseconds. But there are some things you can do to make it not happen in 16 milliseconds. And I wanted to give you an example of a jQuery selector that is a kind of a convenient selector, but when combined with 2 other things, it's like one of those experiments where you combine vinegar and baking soda and it all foams up. This is like the baking soda of jQuery selectors. The visible and hidden selectors, when you use them, they will select visible elements on the page. And of course, you can say, I want to select only the visible paragraphs or visible inputs. And it seems like a pretty innocent thing, but when you think about what has to happen, who knows if that element is visible? The browser knows. So you're going to ask the browser a question about the visibility of an element. It needs to go through, and depending on what's happened, if the DOM has been modified or if the styles have been modified, it actually has to go through the render, layout, and paint. Well, it has to go through the render and layout process again. It may not need to paint, but to answer your question about whether it's visible, it needs to actually figure out whether a style may have changed. So here's a really simple example that I put together. I used the console time API to make a bar that we could easily find in Chrome's performance tools. And I'm just setting a class on the body, I'm removing a class on the body, and then I'm using a selector, p:visible, and I'm setting color to blue. This is kind of abstracted from a piece of real code that I was doing some performance investigations on. And in this case, when I change or remove the class on the body, the browser says, wait a minute, before I tell you if this paragraph is visible, I need to go back through and see if any rules about activated may have affected the visibility of this element here. Now, sometimes browsers are smart and they can determine that without actually going through and redoing the DOM, but it's a roll of the dice. It really depends on what rules, CSS rules, are in the document at that point. And in this case, we lost. It took 30 milliseconds. You can see our time, the second yellow bar down is our console.time, so we can see the exact amount of time it took to do this. You can see a big, long, purplish, bluish thing that says recalculate style. That's when jQuery went and said, what elements are visible, Mr. DOM, Mr. Browser? And it took a huge amount of time. And there's some interesting little yellow triangles there we'll talk about in a second. But you can see the amount of time it took to do that. There was a huge amount of recalculation. But what if we decided that as developers, we could track visibility? So instead of using 2 little dots, we'll use 1 dot, which is a class. Now, quite often, you would not use a class name of visible. You would use some other semantically meaningful thing in your program. But the idea is a class name doesn't make, like selecting by class name doesn't make the recalculation occur, because I'm not really asking the browser anything other than to look through your DOM and see if you've got anything by this class name. Well, in that case, it only took 8 milliseconds. So we went from 30 to 8 milliseconds. You can notice there was no recalculate style while the JavaScript was running. We did not force a layout. We didn't make the browser answer a hard question. And yeah, recalculate style occurred because it occurred afterwards, because we had added or removed a style from the body, and it said, well, I'm going to need to go and recalculate the style anyway, but it could happen whenever the browser had a free moment. So we didn't cause a bottleneck. Now, that yellow triangle that we saw is actually Chrome's way of trying to tell you you've made a very big mistake. So if you hover over a line where you've got that yellow triangle, it actually gives you a huge amount of detail about what happened. This is from a different example, but it shows you that the place where the layout was invalidated was where, most of the time, it's where you've changed the style or class or something rendering related. It might be where you inserted or removed pieces of DOM. In this case, someone added a class to the document, and then the layout was forced when someone tried to get the width of an element in the document, which is, when you actually see the CSS there, it's actually asking CSS of width. So I think a lot of the times the reason why people say jQuery, why jQuery is implicated is a lot of times we're at the scene of the crime, but there's a specific type of pattern that causes this to occur that isn't our fault. I mean, the only way we can eliminate this forced layout is to not do what you ask us to do, which is not try to get the width after the layout was invalidated. In IE11, there are no little yellow triangles, but there's a similar pattern that you can easily find in their UI responsiveness view. You'll see it where there's an offset width followed immediately by a layout. So the offset width is the browser being asked how wide or high is this element. And then immediately it says, well, to answer that question, I've got to go through my records and figure out what the exact height and width of this is based on the new class information you just added. So how do I avoid this? Well, the easiest way to avoid it is never use visible or hidden. I would say that if you can, that wouldn't be a bad approach. But if you want to use it, be aware that if you're using it in big documents with a large scope of information, you could run into a performance problem. The other problem that was going on with this particular example in real life was that they were using classes on the body to flag things. They were using it as a communications mechanism between different parts of the document. They weren't using it to style anything. So these classes were really more like program state than they were DOM state. And it was a waste to do what the way they were doing it. You can use jQuery's data storage mechanism to store data that will have no effect on classes or layout if that's what you need to do. So there were actually 2 ways to solve this here. The visible by itself might not have caused a forced layout, but when you combine it with kind of an inappropriate use of class names, that forced layout. The other way to avoid forced layouts is to just get JavaScript out of the path. Don't run JavaScript. If you're doing animations, for example, use CSS transitions or animations to do that. But there are times when JavaScript is not just causing the browser to be slow, it's slow JavaScript. So here's a real site that I stumbled across called Gimmick Book. And you'll probably now DOS it by all going there at the same time. So you'll say, hey, he's right, it is slow. It's kind of like a Pinterest type of site. It's got a bunch of images, and it's infinite scroll, so you can just keep scrolling and scrolling, and it fills in with more images. And I noticed it was really jerky, especially as you got further down the list. And I was like, I wonder what's causing this. So I thought, being that programmers are always good at guessing bottlenecks, I said, I bet you this is an example of forced layout. I'll use this in my presentation. So, in a picture, here's the problem we have, right? It's a slug on a tortoise. And when I actually looked, what you go looking for, you will find. There was forced layouts. But I want you to point your attention to the details of the forced layout. It says duration 1 millisecond. Well, you're not going to see jerkiness on a 1 second forced layout. And if you look at the timeline view, there weren't, those are like little tiny bars. That wasn't what was causing the problem. So what was? Well, that's where we can turn to the browser's profiler, their JavaScript profiler. When you get a situation where JavaScript is causing a problem, you go to the profiler, you start a profile, you do a few things in the page until you can recreate the problem, you push stop, and you analyze it. And you get a report, and this is a little snippet from that report. This report showed that masonry layout was taking 25% of all the time that was taken during the period where the measurement was done. So masonry layout, that's a jQuery plugin. What's wrong with that plugin? Well, we go down and look, and there's an anonymous function inside an each, and there's some other stuff going on there. I thought, well, this wasn't really clear to me, so I decided to go over and look at IE11's profiler. And this one, I think, really just slapped me in the face with it. It's like, OK, the first column there is the number of times that function was called during the profile. Now, does anybody see anything unusual there? 44,349 calls to function apply. So it's calling a function. It's calling math max. It's slicing arrays. Now, that's bad as well, because when you slice an array, you create a new array. So there's 44,000 extra objects created. And I looked at that and I said, well, gee, there's something going on there. What does that code look like? So there's masonry layout. I printed it using the tools. There's a loop there, and those are really big numbers. So what it was doing, masonry layout, was really never intended for an infinite scroll page. It was intended to lay out a fixed size page. So maybe you have 100 elements on the page at most, 100 little things. But this was combining masonry layout with an infinite scroll page. How long does it take to lay out an infinite number of things? It takes a long time. So the problem here was, it actually was a JavaScript problem, but it was more of a mismatch between two designs. It was like, you can't really, like masonry layout was designed to lay out a small fixed number of things, and you were telling it to lay out, because it was starting at the very top of the page thinking, well, I need to update everything now. But just the little red circle at the bottom, there's our forced layout that we actually did see. It's just that that was the least of our problems, because you get one first layout and 44,000 calls to the function above it. But the moral of this story is that infinite scroll should not be used with full page layout algorithms, because the full page can be infinitely long. And there's a solution for this. Now, if you're the person who's combining the two pieces and don't really know how they work, it's easy to fall into this trap, right? You say, well, I got a layout cool thing, and it's cool, and it works, and I saw the demo page, and I've got my infinite scroll, because everybody thinks infinite scroll is really cool. And when I combine the two, I end up with this problem. But when you think about it from a design standpoint, there's no reason to lay out the whole page. All I need to do is lay out the pieces that get added at the end, because the rest of the layout stays exactly the same as it was. So you have the tools, use them. Let me, I'm going to do something dangerous here and actually try to start a, actually I think I'll start Internet Explorer. I always like to be nice to them every once in a while. So, we're going to go and use we'll use the UI responsiveness view and just watch what happens as I scroll down. All right, I'm going to stop the UI responsiveness view. All right, so this very similar output that you would get from, from Chrome's profiler as well. But you can see the color coding there that shows you what's going on. And initially, we don't get a lot of these little red bars, which are scripting. And as we get further down and we continue our infinite scrolling, we see these little spots of, zoom in, we see these little spots of script activity. And the reason why the bar doesn't get any higher is the browser is basically single-threaded for a lot of the stuff it does. So you don't, even though I have more cores, the browser really only uses one thread and one core for a lot of what it does there. So that's why you see these capping out, the little red bars there capping out basically using 100% of one core. Certain other things can go on in parallel. You see garbage collection is going on. Why would garbage collection be going on? Remember I mentioned that we were creating lots of these slices of arrays and discarding them. So you can see the the good thing about having multi-threading is this guy can be collecting all the garbage that you keep throwing on the ground. So it's an unfortunate use of a core just to fix the mess that you left. But it gives you, as you combine the two, you can see the amount of detail that you're getting out of these tools to really help you zoom in on the problem and try to figure out what's going wrong with it. So let's, as another step, we'll go and do the profiler. We'll start a profile. And again, I'm going to start going down. I'm going to stop. And again, you see, I'm going to look at call tree. There's offsetWidth, 2,000 calls to offsetWidth, which is looking at the width of each one of the elements. The interesting thing about this is, you can also, let me just give you an example of call tree. Here we go. So with the call tree view, you can actually drill in and see what's being called at each point. In this case, you just keep drilling in until you find the item that is taking the most amount of time. So by using a tool like this, you're able to zoom in and essentially find the problem without needing to go through too much effort. Here in this case, we're reverse engineering. I spend a lot of my time reverse engineering sites. Imagine how much nicer it would be rather than going and trying to figure out, like, if you had your uncompressed source, wouldn't it be nicer than having to deal with that? Now, obviously, we can push this little button here, and we can get it to give us somewhat readable code. But obviously, that's not nearly as nice as if we have real variable names, for example. So even if you're dealing with code like, say, a plugin you've obtained, if the plugin has uncompressed source, you want to be debugging with uncompressed source, believe me. Let me go back to my, let me close this. There we go. And like Yoda, I hope I have trained you well. You don't need to balance me on your foot or anything, but I hope you've learned something from this presentation. In other words, I hope you found this talk useful, and if you would like to contact me, feel free to contact me using any of these ways. But this is the end. Thank you very much.